This is a frog. The frog has 5 lily pads in front of it, and its home is the last lily pad. Now the frog can either hop to the next lily pad, or it can skip the lily pad in front of it and go to the next lily pad after that. How many routes are there for the frog to get home? For example, it could go hop, 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 hop. That would be one route. Or it could do skip, then hop, and then skip. Why don't you pause the video and see how many routes you can find for yourself? Now in total, there are 8 routes for the frog to get home. But you might wonder, what if we had more lily pads? What if we had, for example, 20 lily pads? How many ways are there of the frog getting home? Now notice that all of the routes either start with a hop or they start with a skip. Now, if the frog starts with a hop, then it has 4 lily pads left, and then these are all the routes where we have 4 lily pads left. Similarly, if it starts with a skip, then it's only got 3 lily pads left, and these are all the routes where we have 3 lily pads left. So in total, the number of routes when the frog has 5 lily pads in front of it is the number of routes where there's 4 lily pads in front of it, where we started with a hop, plus the number of routes where we have 3 lily pads in front of it after we've done a skip. Now, if we were to define a function f such that f of 5 is the number of routes when we have 5 lily pads in front of you, we said that's equal to the number of routes when we have 4 lily pads in front of you, because we started with a hop, plus the number of routes when we have 3 lily pads in front of you, because we started with a skip. And more generally, if we had n lily pads in front of us, then f of n is equal to f of n minus 1 plus f of n minus 2. And this is called a recurrence relation. Now let's build up a table of values. If we only had 1 lily pad in front of us, n is 1, then the only route we can take is just to do a single hop. So there would be 1 possible route. What if there was 2 lily pads in front of you? Well, you could either do hop, hop, or you could do a single skip. So there's therefore 2 routes. But we said we could find f of 3 by doing f of 2 plus f of 1, where we start with a hop or a skip. So we do 2 plus 1, which is equal to 3. And then again, we can do 3 plus 2, which is equal to 5. And again, we can do 5 plus 3, which is equal to 8, which is the answer we had before when we had 5 lily pads. And we can continue this way. 8 plus 5 is 13. So if we had 6 lily pads, there would be 13 ways. And you might recognize this as a Fibonacci-like sequence, where each term is the sum of the previous 2 terms. So can you work out the number of routes when there's 100 lily pads?